Great, so welcome everybody. I'm Jonathan, this is Mark. We're both from Amazon Web Services. We're part of the OpsWorks team. And we're here to talk to you about kind of the trade-offs that we learned over time for running a single server. What are some of the potential problems with that, and what are some of the patterns that we've seen that work for customers, and how can you maybe achieve like what we call a federated model that gives you some advantages over depending on a single server. So for those who don't know, there is actually a long history of the partnership and collaboration between Amazon and Chef. We have actually two services under the OpsWorks umbrella that offer customers Chef. The first one we launched quite a while ago. In 2013, we launched OpsWorks Stacks, which bundles the Chef client for you and runs it in a Chef Zero mode, where you can execute recipes on demand. And then in 2016, we launched Chef Automate as a kind of managed server for you, so you can run your own Chef server and Automate server, and we take care of the operations. And I think that's when we started to see some of these patterns and observed customers. How do they run their Chef server installation? What are the problems they potentially have? And how can they scale this out? Now, if you joined yesterday's keynote, Barry was talking about these things here, right? Like he was calling out how today there is the need to have all of this kind of fast IT, as he was saying. How can we achieve all of these? How can we be faster in developing software? How can we create this culture of innovation? How can we ship customer value quicker? A lot of these are representing values that we hold up a lot at Amazon. And I imagine that for a lot of you folks here, those are also very relevant things. And the big question is, of course, how do you get that, right? Like, how do you achieve this? There is always not kind of the one thing to do that gets you there. But maybe to share like how we at Amazon approach these things, and how do we at Amazon are trying to make sure our teams are achieving this state. One pattern that you might have heard of is what we call the two pizza teams. So the idea is you have a team that is only as large so that you can feed it with two pizzas. They have to be quite large pizzas, I assume. At least the typical teams and people I've seen, like you need more than that. But the idea behind it is, right, that you have a small group of people that works autonomously, that is has their own agenda, their own goals, they own this particular problem space that you're looking at, and they're accountable for achieving it. But they can also define, how do we get there? How do we achieve this? How do we think in terms of technology, in terms of mechanisms and processes, in terms of tools? How do you achieve that and solve this problem? And because you have that ownership and that flexibility and freedom, they're able to operate a lot faster. They're able to do what they think is the right thing, and achieve like this customer value, and achieve essentially that list that we were looking at that Barry was showing. Obviously, at the same time, you want to enforce certain standards, cultural, technical, security, and so forth. And that's kind of basically every team you have at Amazon is operating with that standard in mind. Now, why do I mention that in particular when talking about Chef and a Chef server? In order to be able to be autonomous, right, like have control over your destiny, you need also to be able to independently operate, right? In particular, like I was saying, in terms of the tools. So if we think about the idea of you're a large organization and you have like a single Chef server, that might be a little bit hard to achieve, right? Like, how can my team that wants to do things slightly differently maybe than your team, like have that autonomy, right? So that's kind of the aspect that we want to focus on today. Like, how do we enable teams to be autonomous, and also in terms of their tools and processes? Now, why might it be problematic potentially to have a single Chef server, right? There are kind of several reasons for that, and why you might run into certain limitations. Some are on the technical level, right? And you could argue those you could eventually fix in terms of availability. Like we as Amazon look at it, right? Like we like to have like our services, or we recommend to customers for their services to run in multiple availability zones in multiple regions, right? Like not have that single footprint that might be impacted because your application is down, or the network has problems, or connectivity between data centers have issues. So that's already kind of one challenge. Obviously, if you have one installation, then you might have issues with, well, how do I upgrade this safely and securely without impacting my production workloads? How do I do this if I have a global team? Like I can't, there is potentially, especially for larger groups, there isn't a time at the day where there is clearly nobody working potentially. So those are some of the technical challenges, but there are also more team challenges, right? Or I would say process challenges, because you might, if you have one server, you might force everybody to use the same version, right? Or the same configuration, or the same setup in terms of your release pipeline, right? Like if we think about things like workflow or pipelines, right? Like if you have just, this is the official setup, that means that everybody has to follow that, and maybe that's the right thing for most of your teams, but maybe not, probably not for all of them. So those are some of the challenges that we think are limiting you if you're running a single service. So what we want to a little bit explore today is the idea of this federated model of how can I kind of get the best of both worlds by, on the one hand, I give each team their own tools, in this particular case a Chef server, where they're free to configure it as they like, where they're free to like use the certain version they want to, right? Like so yesterday, a good example, Chef Automate 2.0 was released. Some teams in your organization might want to adopt it immediately. Some other teams might not be ready yet, or they maybe they want to, but they don't have it high enough on their priority list right now because they need to deliver an important customer feature. Or maybe they have something that isn't compatible and they depend on somebody else to fix that first, and only then they can upgrade, right? So how do you give them that flexibility, but at the same time, there are of course requirements that you want to ensure that there is a certain central capability to audit, to ensure everything is compliant, to from a security angle make sure that you have visibility and control over these. And we want to explore today, like, what are some of the options and how do we think is a successful model, and Mark will give you an interesting demo of how you can set this up and show you how you kind of get hopefully this best of both worlds. And with that, Mark will run us through some of the alternatives to run a federated server.
Thank you, Jonathan. So first of all, I think most of you are aware of that a Chef server is multi-tenant capable. So you can have a Chef server that has multiple orgs, and that gives you a separation of all the teams that are running Chef against one server. So they have their own cookbooks, their own databases. There are no problems with security credentials could be leaked, or secret database or something. So everyone would just use it as if it is their own installation of the server. So it looks like, from perspective of knife, everything is just their machine. So you have this clear separation built into Chef, but you still have one server. And the first thing that comes into mind when you think, okay, now multiple teams in my company using that, how can I make sure that this thing is up and running all the time? And Chef server has for a long time an HA setup that you can use to actually make sure that the server is not going down, or if one of the hosts is going down, then the other one can seamlessly take over, which is great. But Jonathan already mentioned that there is more to that than just this technical problem that you can solve with HA. When you think about, I'm from Berlin, as you might hear. I work a lot with teams in Seattle, and there are 9 hours time zone difference. So think about, okay, so now there needs to be maintenance on that server. Let's say someone needs to install some security patches on it, and there's a downtime that fits well into my release cycle of I need to bring something out to my customers in Europe, while the people in Seattle are just getting up. So there might be a synchronization issue where people have to agree on, okay, now you can do it because it's good time for me and it's good time for you. So for multinational companies, this is a big issue. And Jonathan also mentioned that if you have this one server, network connectivity might be a problem. So if I cannot reach the server somewhere in the US because I'm in Berlin, also my cookbook upload might take a while over the wire. Those things slow you down, and they slow other teams down as well, because if you have to synchronize across teams, that usually requires meetings and talks and agreements, and you know how that goes. So if you have this, oh, do we get some air conditioning? That's great. So if you have this one single Chef installation, I would say, because I would assume that if you have multiple teams running against one server, you already have HA in mind. So you have the single point of truth, which is great because if you think about maybe your DevSec team that is taking care of security and compliance, they want to have this one single point of truth where they can inspect what's going on, who has the right hardening cookbooks installed, what are they running, and is everything okay with our standards. And to have this one server to maintain, this is also a bit easier because you don't have that spread around across multiple regions and multiple time zones. So it's one team that can just make sure that this thing is up and running. And if you need a new org because you acquired a new company or something and you have 5 new teams that need their own Chef installation, setting up those orgs is just a matter of a few API calls. On the negative side, you have also the single point of failure, which is pretty obvious, and we talked about that. Let's say someone compromises this server that affects your whole company instead of just one part of it, and you need to especially coordinate when you do upgrades of Chef software. I don't know how many people upgraded from Chef 11 to 12, but think about this is a scale where you need to make sure that all teams are prepared for that and that it fits into their agenda right now, because they might have other priorities than just going from something that works for them to something that is a lot better. And the next thing that comes to my mind is scalability and load. So this is where it breaks, right? So you can have one installation that has maybe tens of hosts and they can handle 50,000 nodes, but at some point this thing will just be too big to fail. And you want to avoid that you run into load and scalability issues. So the obvious choice then would be that you give every team their own server, which will reduce the blast radius. It's very simple to understand. Everyone has its own server. You have physical isolation or account isolation if you run it in the cloud. And you have also a good benefit in terms of cost allocation. So some parts of your company might be very interested in how much does this team spend in infrastructure, and answering that if you have just a gigantic installation with 50,000 nodes is not that easy, because then you need to have naming conventions and other things. If it is one server that has everything that this one team needs, it's pretty clear to find out what that costs. And the good part is that maintenance now can be done on a per team basis. So when the team in Berlin thinks best time for maintenance and applying security patches is Sunday night, and they can just do it. And if the team in Seattle thinks that the best time to do it is actually Monday morning, they can do it whenever they like, and they don't have to agree on something. And every team has a backup, which is a lot smaller than if you back up 50,000 nodes Chef installation. On the negative side here is now it's much harder to have company-wide policies enforced across all teams, right? So everyone runs their own server, so how do you control that? So as a security engineer, you might want to make sure that everyone has the same policies applied, that has the same hardening cookbooks in there, has the same compliance profiles. And now also all the teams need to think about operation and operating Chef server, which is something, if you use the OpsWorks service, is done for you. So the OpsWorks service manages the server for you, so that is less of an issue. So there is a solution for that. But if you run on-prem, you need to think about that if you need to have the server in your data center and you cannot connect your nodes to Amazon. So okay, let's focus more on how to enforce company-wide policies, because as I said, the maintenance issue is a smaller one, and this one actually is something I thought a little bit about when we had to talk with a customer that had a global footprint, had to install multiple Chef installations, and they wanted to see how they can enforce their compliance profiles across the board, their hardening cookbooks, and that they have auditing capabilities so that they can see if all the teams are compliant. So how can we apply what we learned from something that everyone hopefully adopted already, which is building microservices? So we all know that what we do right now is just software development, and it turns to be at the end some infrastructure that we run. But to develop Chef cookbooks, that's not different than building building software. And if we distribute the software and how to run it, this looks very much like microservices. And the good thing is we can apply this model now to just building chef cookbooks and recipes and so on, because this model is pretty good understood. And so now we have a per team repository in our Git server that has exactly the configuration that you need to run the infrastructure for your team. And you have a company-wide common repository. If you run microservices, there's usually some common modules for security, for authentication that are shared across multiple of your services. And the same would be true then with Chef. You would probably have some hardening cookbooks that you want to apply to all of your servers. And now the task for every team is to regularly merge from the upstream, from this common repository, so that you are always in lockstep with what is in the common repository. And that is a process that you need to enforce in your teams, and where you apply good intentions, but you know how good intentions work. At the end, you might just miss them because you have other things to do and you just forget it. And the guy that is always doing on Monday the merge from your common repository is on an extended vacation. So yeah, that task is lost, and that doesn't help well. So now, if you merge everything from live and you run that, or you want to push that to your production pipeline, when you build microservices, obviously you want to have continuous integration pipelines that do testing of all the code that is there, and you want to have continuous delivery that pushes everything out. If you go into the Chef world, so the policies can be certain cookbooks like the hardening cookbooks or inspect profiles, and then you would say, okay, I have Git and I have Chef and they work well together, and I just use my DevSec cookbooks for the Corp Linux baseline and my Corp audit cookbook, and I just use that in my works file, upload that to my server, and everything is fine until someone forgets it. So, as you probably know, is the best way to deliver software is through a full CD pipeline, and what you need for that is a source code repository, which is probably something like a GitHub, Git, code commit, something like that. So where everyone pushes this code, you have peer reviews for new code, and afterwards you need to have some tests, and Test Kitchen, Food Critic, Chef Style. Those things have to run continuously against your code, so that you make sure that your code is always well tested before you push that to production. And you need to deploy, which is much easier in Chef than in other environments, because you just need to deliver the cookbooks to the server, and the rest is taken care for you. So how does it look like now? So you have a couple of Chef servers, and all of them have some cookbooks from the DevSec team in your org, and your infrastructure cookbooks that you anyway have. And you push them to your Chef server, all your nodes picks them up, and everything looks totally fine. But there's a little bit more to it, and I would like to go to a demo now, because I talked a bit too much, and I'd like to show something that is a bit more practical. So what I want to show is how you would develop some common cookbooks, how to push them to the server, and make sure that you don't rely on good intentions, but you can enforce that those compliance profiles and cookbooks are run by every team, no matter if they think about it or not. So what I used, well, I need to probably push that over here. So what I use is AWS Code Pipeline. AWS Code Pipeline gives you the ability to have multiple steps defined that do certain things. And the concept is the same like Jenkins. So if you run Jenkins effectively in your org, that is totally fine. You can just replicate the same steps, and maybe you have it already. So the first step usually you should just check out the source of the cookbooks and compliance profiles from a repository. Then the next step will run Test Kitchen, Chef Style, Food Critic on it to make sure that everything looks good. And then we have a manual approval step here, because if you want to ship well-tested cookbooks and so on, you can just skip that one, but you can also just say, okay, I want to be in control of when that is hitting my chef server. That manual approval step could also be something that is a time-based approval step, where you say, okay, I don't want to ship things after Friday afternoon until Monday morning, because I don't want to have my servers getting something new on Sunday when they have the next run. So you might want to limit the blast radius of those things. So manual approval step or whatever works for you. And the last step, because you don't have to build cookbooks really, is just that you upload. So under the hood, I use Code Build, which is another service of AWS that is just launching a small instance for you, running a couple of scripts on it, like Test Kitchen, code checkout, and then the knife upload to your server, or the Burks upload. Okay, so I talked about that you want to have cross-cutting concerns like security in that pipeline enforced. So what I have here is my audit cookbook from my DevSec project, and what it has is just the normal compliance audit cookbook that you might know, and we configure it to have the recent Chef client version inspect profile, bear with me with the naming, in version 0.4. And what it does is it checks if you have a cookbook or you have a Chef client running that is at least version 13, right? So who is still on Chef 12 clients? Yeah, you might need that. So there will be a blog post that gives you all the setup that you need, and this little profile, it's only 2 lines of code. If you look here, it's just getting Chef client version and then the scan and giving back the major version. So writing inspect profiles is super nice. That doesn't take you long, and you have a good overview of what you are running. So if I'm in this DevSec group, I want to make sure that every one of you knows what is running, and if you have some work to do to upgrade to Chef 13 or even 14, which is out for a couple of weeks now. But I cannot enforce it on you. If I enforce that I upgrade for you, the Chef client, probably most of your stuff will just break. And I cannot do that. And I don't want to block your teams, but I want to surface, hey, you have some work to do, better get started now. And you can see how that goes for you, and you can start working against it. And at some point, you can twist the screw a little bit further and say, okay, now I enforce on you that you have to be upgrading to Chef Client 13 or later. So that's cool. So what I do now is I would just use the normal Git flow and would just update that one. And that's too small. Someone needs to say stop when you can read it. Okay. So if I do git status, then it should be okay. I'm clean. Perfect. So what would you do? So you just recognize that Chef 14 is a new thing, and you want to make sure that all the nodes that are out there not only are compliant against Chef 13, but maybe 14, and just make sure that you close the gap a bit further, and you want to make sure that everyone in your team knows about it. So if I go to my instance here, I have one successful node here. That's running every minute, and it has a run list where I have the audit cookbook, a web server on it. This looks all good. And if I go to compliance, I'm compliant, which is awesome. And now my DevSec people say, hey, 13 is not a thing anymore. Let's make the rules a bit tighter. So that's pretty easy. So just search for 13 and then change that to 14. And that's all you need to do to just bump the version and make all your engineering teams cry a bit. And the next thing you need to do, you need to bump the version here. because otherwise it doesn't make any sense. So that's about it. So my my DevSec team said, okay, it's Thursday afternoon. Let's make them uncompliant and let them figure out what they have to do after the weekend. So I think that's it. And when I push that now, so, and then git push. Okay. And the pipeline that I showed you is the pipeline of my DevSec group. So if I go back here, it will shortly recognize that there was a new version pushed for that one cookbook, and that has nothing to do with the cookbooks that I run with Burks and install it on a server directly. There it is. So the code will be checked out now. And right after, I run the normal tests that you have. So chef style and food critic, and I skipped the test kitchen stuff because it takes too long in the demo. So right now the whole pipeline runs in 5 minutes. Otherwise it would be a bit more. So I want to save some time here. So, and if you go here, you can wait a second. All right. So what I do here, so this is what I do, right? So I just do chef style and food critic, and usually you would also have test kitchen in here. And this is everything you need to define what is running in this one build step. And the next build step is then that you want to update everything and push it to the servers that are across multiple teams spread out in your company. And everyone will just run those inspect profiles in their environment, and they have not done any change on their side. So the chef client is running continuously. We push cookbooks to the server, and they will be picked up automatically. And that means that no infrastructure team needs to think about the audit cookbook at all. They don't have to think about which profiles have to be installed on the server. And they will just get those changes pushed from the security team. So you go from this good intentions mode into we can enforce compliance and security. So let's go back to the pipeline. Maybe I just click to, yeah. So now the first code build is doing the check style stuff, test kitchen, and so on. And the next step will be the approval. And afterwards, we push the new compliance profile that I created to the server. On my chef server, I haven't changed anything. And my infrastructure team didn't do anything like a Burks install, Burks vendor, Burks cookbooks upload, nothing like that. The only thing they have to do is that they ensure that they have the OpsWorks audit cookbook in their run list. And I got blamed about the run list and roles thing 2 days ago, and I know it, and it looks like policy files are now a thing again. So the only thing you need to do is you update it in your role and have somewhere the audit cookbook. And this is everything your team needs to do. And as the DevSec team, I would have a test in every pipeline that makes sure that everyone is running that cookbook so that I can enforce compliance across the board on multiple machines, so that no one is just removing that one line and is compliant all the time. So otherwise, they have a way to sneak out, and no one wants that. Okay, this will take another minute, I guess. No, not too long. Okay. Okay, so now I say enforce chef client 14, and then I approve it, and then the next step will upload. So if I go to the Chef Automate server, I have here my profiles, right? And I tested it a little bit today. So I have version 0.3.0. 0.4.0, and now 0.5 will come. And those things will just be uploaded through the pipeline. So no one needs to go to the automate UI of 50 teams and upload the profile, because that is not automated, and we want to automate to make things faster. So this will just be shipped here. And then because my audit cookbook will always use the latest version of the compliance profile, it will just run that. And I hope that my node is then not compliant anymore. Okay, so upload happened. Let's see if that actually worked. Praying to the demo gods. Not yet. Oh, okay, great. Yeah. Religion is hard. Let's see. The pipeline? Ah, wait, yeah, it's not, it's, okay. It wasn't done yet. It's a visual bug. That's much better than a real one. Okay, whew. Happy about that. I thought I forgot to update the metadata, but I did that, I think, so should be fine. So let's go a bit back to the code because it takes a bit. So the upload step. So what we do here is we just run inspec against the API so that we can log in. So you need to have kind of a, yeah, like probably every one of your Jenkins servers had kind of a deploy user. The same concept here. So you have one token so that you can upload the profiles to the server. For other things like SSH baseline, Linux baseline, and so on, you would not only ship the profile, but also the cookbooks, the hardening cookbooks in that same thing. So you just do Burks install and upload here, and then you upload the profiles, and the upload of the cookbooks will be taken care of in that pipeline too. And I hope that this now happened. It's still not. Yeah. Makes more sense if you have a lot of teams than just one guy standing in front of an audience. And I love to wait. We wanted to tell things about fast IT, right? So if you go to that build step itself, oh right, cool, it succeeded. So you can watch those steps that happen in between. So the build spec file is only giving you those couple of triggers here, and then you can see the whole output of what happens there. So it's basically the same concept that you would have with Jenkins. I just like that a bit better because you have this one file that specifies what has to run as the build step, and with Jenkins this was a bit more of red tape, at least when I used it last time. So now I hope everything's uploaded here and I have a new profile. Okay. Wow, super. Okay, and now I can even inspect the code, and it shows me, okay, it should be greater than 14. So when my next node run is happening, it might have happened already because I run every minute. Okay, need to wait for another minute. Great. So when the next node run is happening, it will automatically pull that new profile in through the audit cookbook, run it against my node, and will figure out that, hey, my node has Chef Client 14 on it and is not compliant anymore. So let's see. At some point, yeah. Okay. Yeah, a minute is sometimes a bit longer. It feels at least very long. Okay, now it ran. I'm still compliant, that's not good. It's very unexpected. I forgot something, I'm sorry. I didn't use the, okay, wait a second. So it will come, I'm very sure. So What I showed you is that you can have a team that is completely separated out from the teams that run actually the infrastructure and that want to make sure that they can run fast on providing cookbooks for their infrastructure, making sure that they have the maintenance whenever that fits to them. But there are some parts in your company that don't want to wait for anyone, and they don't want to preach to people to update to the latest security cookbooks, to enforce something. They want to push compliance and they want to push security across the board because they are the ones that get yelled at if there's a vulnerability that was detected and they had a task to actually update the whole company to have the latest SSH client or something like that. And one of the servers was not compliant. So they have to report on it. They need to ensure that they can say, okay, we are done with the task, everything is updated. And that's why they don't want to wait for teams to pick things up. So I hope at some point we have a run that actually pulls the new cookbook. No, it doesn't. So something I forgot.
Yeah, as Mark was saying, right, like the idea is that you basically separated the responsibilities. So there is a central team that is able to define audit and security scans and compliance. And with things like Automate, you can even have like a central automated installation that aggregates information of the other servers. And then each individual team can have their own Chef server, run different versions potentially, run a very different setup on how they deploy. But as long as you enforce basically using or consuming that central repository, you're able to make sure everybody is on your radar in terms of the compliance audit and scans and so forth. And that's a model that we've seen work very well for larger teams, for distributed teams, and where this way you can have dozens of Chef servers or Chef Automate installations, but still maintain that central control and audit capabilities. And let's see, maybe.
I found it. My DevSec team did only half of the work, so it needs to enforce the new profile. So bear with me, sorry for that. And now, if you would have another 5 minutes, I would show you the result of not being compliant anymore. But yeah, you know how that goes. Yeah, versioning is hard. Okay, so next run it will just say, okay, now I enforce in my attributes that I picked the right compliance profile, which is 0.5, that will then enforce the new recipe and make sure that everyone is not compliant anymore. That is not yet on Chef 14. Okay.
Cool. Yeah, while we wait for that, we can maybe kind of quickly wrap up and see if there are any questions. So what we're trying to show you today that at least we believe that if you want to achieve that fast IT, you need to make sure your teams are independent, they have separate ownership and accountability. And that is very important also with the tools, that you give them enough freedom and flexibility. And one way if you use Chef is like you can give them their own Chef server installation, but still have that central control. Kind of by applying the same best practices that we learned from software development to infrastructure management, essentially, right? Like divide and conquer, have consumable kind of central control, right? Like that as a small team, I consume those central audit inspect profiles or cookbooks, and that's how I get this central control and audit capabilities for the central team, but I can still free to move on my own speed at my own account for my infrastructure that I need for my project. And obviously, right, like CI/CD is a big part of that, as we were showing with AWS Pipeline and Code Build, but obviously there are other alternatives how you can build that, right? I think the idea is more important than the particular tool. And with that, thank you very much. Hopefully in a minute, the example will work. Are there any questions? So the question is, how does this scale? Are there any limits in terms of accounts, servers, or so forth? So this model pretty much scales indefinitely because you have no central component, right? Like it's because you're just enforcing consuming a Git repository with the inspect files and the cookbooks. So there is in that sense no one component that apart from source code that you're just consuming that needs to scale, right? Like there is not a single server that has to have a certain capacity or throughput or anything like that. It might be a little bit different if you want to have a central Chef Automate installation with a central web UI to be able to look at that. But as long as you're able to query the aggregated servers, there is in that sense no limit. So the question is, how many nodes can a single Chef Automate server managed by OpsWorks handle? That depends on what size of the instance you pick. So you can pick a smaller server that has obviously less capacity, or you can pick a larger one, like the largest available EC2 instance, and that can go to thousands and tens of thousands of nodes. Ultimately, at some point, like the recommendation would be to have an approach like this, where you don't have just a single instance to manage, let's say, 200,000 nodes, because, like I said, at some point, even though it might be like physically scalable possible for the one instance, your concern is that if I have a single installation that hundreds of thousands of nodes depend on, probably that's a bad idea, and you want to have, again, the federated model where you can have dozens of these, or 2 or 3 to begin with. Like that's from our experience usually why like no customer really hits that potential limit of how many connections can a single server handle, right? Ultimately, it's a Chef Automate server. Cool. So I think we're out of time. Thank you, everybody. And we're available at the AWS booth if you have any other follow-up questions.